Hello, my name's Danny Faulkner. I'm an astronomer. I received my PhD in astronomy from Indiana University. For 26 and a half years, I was a professor at the University of South Carolina, Lancaster, where I taught astronomy and physics. Upon my retirement from the university, I went to work for Answers in Genesis as a staff astronomer, where I was there for 12 and a half years. I graduated in the first graduating class of Dayton Christian High School in Ohio. And they wanted for each of the seniors a life verse to put in the yearbook, and I guess for graduation as well. And of course, you had people with Philippians 4:13 and other common life verses, but mine was a bit different. Mine was, "The heavens declare the glory of God, and the sky above proclaims his handiwork," Psalm 19:1. And I'm sure that many people at the time who didn't really know me very well may have looked at that and wondered, that's a weird life verse. And maybe years later, looking in the yearbook, they thought that. But if people followed up what happened to me, they would understand. And at the time, some of the other students understood, because you see, a couple of years before that, as a sophomore in high school, I decided that was God's calling in my life to be an astronomer and to share the wonder of God's creation with people. And what better way than to share that wonder and beauty with astrophotography? And you may wonder, well, what's astrophotography? Well, it's basically the photography of stars and other celestial objects. And there are a couple of ways you can do this. One way is to simply take a camera and open up the lens and take pictures at night, just on a tripod. You've got to take some long exposures with high ISO ratings, high sensitivity ratings, because starlight is very faint. Another way is to detach the lens from the camera, get a special adapter, put it on your telescope, and use the telescope lens or mirror as your camera lens. And over the last decade or so, I've done quite a bit of astrophotography, learned a lot about how to do this, and taken some pretty cool photographs, I believe. For instance, here's one that I took at a Grandview Camp in eastern Arizona near Eager and Springerville. It's at 8,300 feet elevation above sea level. It's about a 4-hour drive to one direction to Albuquerque and the other direction to Phoenix, so the sky is really dark. And being in the desert of Arizona, it's dry, and elevation of 8,300, it's stupendous. And you'll see some ponderosa pines down here. And near the middle, there is one bright star. It's not exactly at the middle. Right there is the middle. That is a star Polaris. And this is a half-hour opening. I had an ISO of 100 in case you're interested. Normal camera lens, open the widest angle I could get. And ran for 30 minutes. And so it goes to 1/48th of a day. So each one of these arcs is 1/48th of a complete circle. They get smaller as you go towards the middle. This is probably one of my best, probably my favorite, we call these star trail photos. There's a little bit of red and green on the horizon from a faint aurora that night. I didn't notice that till later. I didn't see it with the eye because it was too faint. You'll see different colors of stars, blue and orange and white and red. That's due to the different colors of the stars. Then there's kind of a smear of light up here amongst the stars. That's the Milky Way. It's diffuse and gets speared out very nicely. And I do this a number of times. Here's another one I took. I believe this one was, not sure where I took this. I'll have to look it up again, but you got some trees down here in the lower part. And again, Polaris near the middle, not exactly at the middle, and stars, trails all around there. Here's another one that I've taken. Again, I take these over and over again. This may have been back out at the camp in Arizona as well. I've also experimented with time-lapse photography as well, and this is what we have in this one. This is taken back home in northern Kentucky. The peak of my house is right here, and Polaris is right there. Here's the Big Dipper. You can see the bowl here and the three handle stars. There's another star close to the middle one there. If you take the two stars on the end of the bowl, they point towards the North Star. And the Little Dipper is here. 1, 2, 3 stars in the handle and the bowl as well. This is one of my first attempts at doing time-lapse. I took about a little over 100 photos over about an hour. And then I just put them in a little utility to put them together in a time-lapse. And as I let this go in a moment, you will see that all the stars will move counterclockwise. The Big Dipper will swing down here, but the North Star will remain relatively fixed. So let's take a look at that. And there it goes. And when you watch this, you may want to stop it and rewind it, check it out a few more times as it does that. So that's just an hour worth of exposure. Now, I also do, most years, I do a Grand Canyon raft trip for a week. We camp out along beaches along the way, and at night, we look at the canyon by day. We do geology by day, astronomy by night. That is if I can keep people awake. And it may not show up here immediately, but it will in a moment when we start running it forward. There's a notch here in Canyon. That's Marble Canyon, up into Grand Canyon. The river goes down through it, and the stars are here. And I'm going to run this time lapse, and you are going to see the stars go through like that. The little streaks here and there are actually planes and satellites. The bright star there is Jupiter. You'll see a green flash occasionally. That's my green laser. There's the Milky Way. You'll also see sometimes a little bit of red light flashing. Those are from some of the campers. Now, I must tell you that each one of my photos is typically 12 or 13 meg. And when I make a time-lapse video over several hours, I'm taking hundreds of photos, and you can't possibly keep all that resolution and light and so forth in the video. So I took one of the pictures out of this, one of the stills, and show you what an individual frame looks like. It's much more impressive when you see that. You see the Milky Way here with the dark clouds and emission nebulae and bright stars showing up, and again, Jupiter there in between the canyon walls. And I've done time-lapse a number of times showing the Milky Way. This was taken from the side yard of the president of the Arizona Origin Science Association. You got the Milky Way sliding across the trees there. Again, you'll see many planes zipping by. And this goes over several hours. I just set the camera up and let it run. I've got a programmable camera that will let me to do that. So it's really a joy to do these and share these with people. And I like getting trees or other things in the foreground. I don't get any trees down on the canyon, but I do get them outside the canyon and other places. Really, I never get tired of looking at these. Now, this was looking towards the south. When you look towards the north, the motion is counterclockwise because the rotation of the Earth causes everything to swing around a point we call the North Celestial Pole. Looking southward, there's a South Celestial Pole, but it's well below the horizon. And since I've turned around, the motion is now clockwise. It's the same motion east to west. When you look northward, it's going to be counterclockwise. When you look southward, it's going to be clockwise as you do these things. So, I've been to the Southern Hemisphere a few times, and so one of my trips to the Southern Hemisphere, I set a camera up, and I took pictures looking to the South Celestial Pole. Now, the center of rotation, it's going to go clockwise, and the center of rotation is about right here, I believe, and somewhere around in here. You see there's no South Star. There's a North Star, but not a South Star, so it's harder to find the point of rotation there. So I'll put it in motion. This goes on over several hours. And you get the clockwise, not counterclockwise, clockwise in the Southern Hemisphere, going around. And we had kind of a bright moon that night, so it's not as dark as it could be. The lights flashing on the trees, those were cars turning around the parking lot where I was. And again, some clouds show up at the end. I showed you some photos of the Milky Way, and the Milky Way has just millions and billions of stars. And it's this kind of thing that causes me to reflect upon Psalm 147:4. He determines the number of the stars. He gives to all of them their names. You know, we only have proper names for only a couple hundred stars. We do have catalog entries for many, many other stars. But think about the Lord naming all the stars and counting them. We can't count them. We can only estimate them. But, you know, if God's the creator of everything, He created all the stars, numbering them and counting them and naming them, that's pretty easy, actually, compared to that. Here's another view of the Milky Way taken from the Southern Hemisphere. I took one of the stills out of the pictures, the time lapse I did in South Africa. You've got that's Jupiter there amongst the Milky Way. There's the dark lanes running the Milky Way. The neat thing is the center of the Milky Way is bulged, as you can see here. And for us, in the Northern Hemisphere, it doesn't get very high in the sky, but in the Southern Hemisphere, say in South Africa, it is directly overhead. This is probably my best Milky Way photo. I took this from the Grandview Camp in eastern Arizona, and you can see the thick bulge here that kind of tapers out as it goes up this direction. That's about as high as the nuclear bulge of the Milky Way gets. And here's another one from another trip in Grand Canyon back several years ago now. You can see the Milky Way hidden behind a rock partially. This orange-looking star, very bright, that is Mars when it happened to be very close to the Earth. that year. And again, when I look at these Milky Way pictures, I think of Isaiah 40:26. Lift up your eyes on high and see. Who created these? He who brings out their host by number, calling them all by name, by the greatness of his might, and because he is strong in power, not one is missing. There are other things, though, that God tells us about. In Genesis 1:16, it talks about day 4 creating the heavenly realm, the astronomical realm. And it says, and God made 2 great lights, a greater light to rule the day. And that greater light to rule the day, of course, is our own sun. The reason why, I think, one of the reasons why God didn't see fit to use the name of the sun there is because it's a pagan name. We have pagan names for our planets and the moon and the sun, and he didn't even want to give any kind of credit to them at all. So he just said the greater light, we can figure that out on our own. And I've been taking photographs of the sun for about 10 years, and it's a tricky thing to take photographs of the sun because you got to know what you're doing on the exposure times, and I was overexposing it quite a bit. It took me a couple of years to figure out how to do it right. But this is a photograph of the whole sun, and you see some sunspots here, and you can see the darker inner portions called the umbra, the outer portions kind of gray. We call that the penumbra. And sunspots look dark, but they're not really dark at all. They're just not as bright as the rest of the sun because they're cooler. The photosphere of the sun, the yellow part you see there, is around 10 or 11,000 degrees Fahrenheit, and the sunspots are chilly 7 or 8,000 degrees. I like to say that people from Phoenix are thinking of moving there to get away from the heat. And when I show people views of sunspots through the telescope, the most common response I get is, oh, those tiny little things. Well, the moon is far larger than you think it is. Here's another photograph I took of the sun. And I usually take my photographs, and I don't have Photoshop. I send it to a friend of mine who does and knows what he's doing, and he kind of cleans them up for me. He has to brighten them up and so forth. Here's a nice sunspot group down here and a couple others, but he took the liberty of photoshopping in an image of the Earth there. That little blue circle there, that is the Earth to scale. You could put 109 of these side by side across the Earth's surface. So when I look at sunspots through the telescope, if I see one that's about 1% the size of the sun, I'm thinking that's the size of the Earth. So when people tell me, oh, those little things, those tiny little things are seen on the sun, well, I'm telling you, the sun's much bigger than you think. I tell them about 109 Earths side by side. So some of those spots you're looking at are actually larger than the Earth. And of course, going back to Genesis day 4 account, the second part of Genesis 1:16 says, and the lesser light to rule the night. And again, it's talking about the moon in that particular case. And I've taken some photographs of the moon. This is one of my first photographs I took of the moon. I used a 3.5-inch Questar telescope. That means the mirror is about 3.5 inches across. The focal length, however, is, well, I can't reach that far, I don't believe. Maybe I just barely can. It's 1,300 millimeters. It's a very long focal length. If you know telephoto lenses, you know that's a whale of a telephoto lens. And this has not been cropped. It's the actual field of view in the telescope. And of course, you can see craters here in the southern highlands. You can see fewer up here because you've got Maria here, the volcanic plains on the moon. And the southern highlands here, you can see the craters look best along the terminator, that division between night and day on the moon. That's because the sun is just rising there, and any shadows cast by the crater walls are really long, and it makes them look very stark and rugged. Over here, the sun's more overhead, and you're not getting those long shadows anymore. It gives the appearance the moon is far more rugged than it actually is. Now, I've taken photographs with other telescopes. This one, I used a 126 millimeter refractor. This is about 5 inches across. Focal length only about half that of the Questar, however. And I use a different camera here, a specialized camera for it. And this is much bigger, brighter. Again, the southern highlands showing up in there. And this takes zooming very well. I cropped this and zoomed part of that, and you can see the fine detail that you can get. And I hope to, with time, improve upon some of these photos. Now, taking photos of the planets are very difficult. I have here a photograph of Jupiter, and if you look closely, you can see a couple of dark bands in the atmosphere of the planet. They run parallel to the equator, so the poles are up here and down there. And that looks close to what I might see with the eye looking through the telescope, except that I'm missing the Galilean satellites. There should be 4 little natural satellites or moons orbiting around. They look like little stars. I'm not seeing those because the camera doesn't respond to light the same way the eye does. The eye responds to light logarithmically, which means it compresses big differences in light, and that gives us a large dynamic range. We can see very faint things, we can see very bright things, but cameras cannot because they respond linearly. If you double the amount of light, you double the response. And so you have to play around with the adjustments on the camera, the aperture size, the sensitivity setting, the ISO, and the exposure time. If you take a relatively short exposure time, which I did here, you can pick up some of the dark bands in the atmosphere of the planet. But on the other hand, you don't see the natural satellites. But if you take a longer exposure, as I've done here, same night, same telescope, I now can see the 4 Galilean satellites all lined up, 3 on one side, 1 on the other. But look at Jupiter. It is overexposed. Now, one of the neat things about the eye is the fact that you can see both the dark bands and the Galilean satellites at the same time, but the camera can't do that. The only way you could do this would be to fake it, block this out, and insert the other photo in its place. And I don't do that sort of thing. I like the way it looks either way, but the eye sees it much better. Now, my absolute favorite thing to look at through the telescope has been forever. I first saw this in September of 1969, and that's the planet Saturn. And I choose the same telescope and camera to take this photograph. You can see the rings, the little dark bands a little bit up close, and you can even see a shadow of the planet on the rings to that left side. Now, with the eye looking through the telescope, I can see some of the natural satellites or moons of Saturn, but to photograph them, I have to take a long exposure, which I've done here. You can see it's Saturn because, well, it looks like a flying saucer. Those rings are elongated, and I have marked here 5 of the Galilean satellites, 5 of Saturn's natural satellites or moons. That one that's not marked, that just happens to be a star. Okay, I used the Questar telescope to photograph a lunar eclipse about 7 years ago. And this is taken during totality. I think the ISO is around 400 or 800. It's a 13-second exposure. The thing is totally immersed in the Earth's umbra, the dark shadow. The reason why it looks lighter near the top is because it's near the edge. The edge of the shadow is up beyond where the moon ends there. And the shadow of the Earth is not entirely dark. The atmosphere of the Earth bends light around the edge, and so you fill light into that otherwise dark shadow. It's still pretty dim, but it's got some light, and it's going to be red because light, as it passes through the atmosphere at a grazing angle, scatters out the shorter wavelength, the blue light, leaving the red. That's why sunsets and sunrises are colored red. By the way, there's a bright star, well, not a bright star, there's one star there. Typically, when you take photographs of the moon, you can't pick up the stars because the moon is too bright and the exposure is too short. But during totality of total lunar eclipse, you actually can pick those up. That night when I was looking through the telescope at the moon, it looked larger than it normally did. I picked up on that because I looked at the moon quite a bit with that telescope, and I reasoned that it probably was near perigee. You see, the moon's orbit around the Earth is not a circle, it's an ellipse. It comes about 14% closer at perigee, the closest approach to the Earth, and that it does at apogee. And I looked at it, I thought it must be near perigee, and sure enough, I looked it up, it was within a day or so of perigee. So I waited 9 months when the moon was full again, where I could look at, take a photograph when it was near apogee. And I'll show you that in just a moment. But I want to show you a couple other photographs I took. I had to crop these, shrink them down and crop them a little bit. This is a partial phase, about a half an hour before totality. And can you see the shape of the Earth's shadow on the moon? Well, that was before totality. Here's one about a half hour after totality. Now can you see the shape of the Earth's moon? Well, I'll help you out. I'll draw it in for you. It's a circle. And that's one of the arguments that people in the ancient world use for the Earth being a sphere, because during any kind of lunar eclipse, the shadow is always curved. It's a portion of a circle, and that can only happen regardless of orientation if the Earth is a sphere. Well, as I said, it looked bigger that night of the total lunar eclipse, and so I waited 9 months, and I looked at it again with a telescope, and I took the photograph on the right. Full moon, not eclipse, very short exposure as opposed to a long exposure here. And these are not cropped, they're not expanded, they're not, well, they're cropped a little bit, but they're not changed size at all. They're done at they're reproduced here at the same size. And you can see that the moon here at perigee is obviously larger appearing than it is at apogee. When the moon is at perigee and it's full, they sometimes call it a supermoon. You may have heard about that. People imagine the moon's going to be this huge thing in the sky. Well, it doesn't really look any larger than to the eye, because the eye is notoriously bad for estimating sizes of things. You can't put them side by side, but the camera is better than the eye in that, because it can't be fooled. It can actually tell them apart. And I think, again, of verses like in Psalm 89:37, like the moon, it shall be established forever, a faithful witness in the stars. God made it. God can use it for whatever he wants to do. Now, there are meteors. I've taken photographs of meteors before. This was my first meteor photo. I now have about 150 of them, but this is my first one. I'm kind of partial. And it's in the summer in the Perseid meteor shower. I set it up my deck up behind my house. And you can see this trail rising upward like this. It starts off kind of green, becomes more orange before becoming violet, and then finally ending there. I don't know if you can see it or not, but there's another streak over here. I saw this with my eye. I did not see this. This is a satellite that I picked up. It's too faint for me to see readily, but I did pick it up with the camera. On another raft trip, sometimes I'm in the canyon in August when the Perseid meteor shower is on. So one night at one of the large beaches we were at, I set up my wide angle. I have a wide angle lens, and I captured a Perseid meteor right there. Came down in this case, but there's kind of a fuzzy patch here near the middle. That's the Andromeda Galaxy, the most distant object you can normally see with your naked eye. It's a couple of million light years away from us. Actually, on the original, you can identify a bunch of other fainter objects as well, but they're not going to show up on the screen here at all. Here's another meteor photograph. It may have been taken on the same trip. It's another Perseid, the green and the orange and purple and everything. And this is part of a time-lapse video, and I'm going to just let it run. Notice where this is down here, and notice when you see it in the time-lapse video. Here it goes. And the stars are spinning around counterclockwise. And keep watching down there. Keep watching. Do you see it? There it went. And now the night is going to end. Forget those planes moving across, but the sun's going to start rising and dawn approaches. Here's another one of these ones I did time-lapse. I did through the canyon. You got the canyon walls there. You got planes going by. You got the Milky Way streaking across. And then watch what happens. The sky will, there's Jupiter. The sky starts to brighten because the moon has risen, and you start getting the shadow, the brightness of the moon going down the canyon wall. That's not sunlight, that is moonlight doing that. Unfortunately, at the time my camera, I had to work manually. And about that time, it was after like 1:30 in the morning. It's the first night. I was very tired and I had to quit. I wish I could have gone on, but I couldn't stay awake any longer. Since then, I've gotten another camera that I can program and run for almost 3 hours without me attending to it all. So I can sleep while I'm working. At the Grandview Camp again, I've seen the zodiacal light many times. It's a glow of light on the horizon before sunrise around September, or in the morning, in the evening, the glow in the west. After sunset in March. That's this glow right here, that glow right there. That's sunlight bouncing off of the dust in the plane of the Earth's orbit around the sun. I've photographed it a few times out there. A better one might be from here. This is part of a time-lapse sequence I'm going to show you. The Milky Way runs down like this, and the zodiacal light is going up like that, like a triangle, that sort of shape. Now this is an airplane. Just ignore that. It's behind a ponderosa pine tree. But what I like about this one is I captured two meteors. There's one here and a smaller one right there. By the way, here's Orion, the 3 belt stars, the sword, 2 shoulder stars, his head, his 2 knees. Down here is Sirius. You find that by pointing the belt stars to it. Procyon, Castor, and Pollux. The other brighter stars are those 𝘉𝘠𝘰𝘠𝘺 twins. Okay, I'm going to put this in a time lapse, and I want you to watch for this and notice how this wedge of light builds very slowly as the night progresses. This is looking in the morning. It's starting to build. Now it's getting brighter and brighter and brighter. It's really getting cool, and then dawn comes and ruins it. So I think it's a pretty cool impression. And here is another time lapse I did another year that I was there. You can see Orion rising over there, a bunch of planes zipping by. There's the Zodiacal light building once again, and building. All those planes heading toward it, looks like. And then dawn once again approaches, and a new day. Back in 2020, we had a fairly bright comet called Comet 𝘉𝘠𝘠, and I took it moved very quickly. It came close to the Earth. So I went out, this is my neighborhood, had it walking around on July 8th. It's above a tree here. Two stars have been circled, two bright stars, and there it is above this particular tree. Now I went out 5 mornings later to take a look at it. It's in the morning sky, and it's the same time, but the stars have moved up higher. See where they are here above the trees? They're a little higher here at the same time. The reason why they're higher is because the seasons are changing. And I have the comet pointed out on both of these. You see the head of the comet, and you see the tail streaking upward. It's changed direction because it's orbiting around us and the sun, moving away from the sun at that point from our perspective. So two pictures of Comet 𝘉𝘠𝘠𝘺 that then switched into the evening sky a little later. And so then the next photograph is a little bit of a time lapse I put together. It's not a real good one. I did a few things wrong on it, but there's the comet, and the stars and the comet are going to set. I had to keep changing the exposure time because the sky got darker, so the brightness is going to change quite a bit. It's kind of jerky, but there it goes. There goes the comet setting down lower in the sky. Meanwhile, back at Grandview Camp, I got a time lapse I did. I got Jupiter and Saturn. It got dark, and all of a sudden it got bright because the moon rose. And that light down there, that's not sunlight, that is moonlight. And that light flashing around back and forth, that is a truck and one of the staff getting ready for the camp that's going to start the next day. I've photographed the sun during a total solar eclipse. This is from 2017. You've got some nice sunspots, and you've got also the moon moving across from upper right to lower left as it moves across. And then during totality, I took the filter off, and this is one of the photographs I took then. You can see those red prominences in the photograph. Those are loops on the edge of the sun, and the inner corona showing up down here. It actually goes out much farther, but the telescope field of view is so small that I can't get it anyway, and it'd take a long exposure to get it. And in 1979 was my first total solar eclipse, and this is a photograph of what's called the diamond ring effect. As the eclipse is ending, the very first bit of the sun peeking around to, say, a crater on the edge of the moon produces that. It only lasts for a fraction of a second. It's not there very long, and you better not be looking at it because it's dangerous. It can burn a bad spot in your retina, so you need to not be looking at it. Try to use your camera to see that, find that with a photograph. Here's another time lapse. This one has, I believe, more moonlight on it than the other one did because I used a programmable camera on this one. And you'll see stars going through. Here comes the Milky Way. And then if you see the sky brightening up a little bit, it's because the moon rose. And again, it's not sunlight, it's moonlight that's doing this. There's the Milky Way in all of its glory, doing a nice job coming across. And now the moon has risen. And now the moonlight is making it into the canyon walls and coming down, creeping down, creeping down. Again, that's not sunlight, it's moonlight. And it comes on down. Depending on the angle of the rock face it's on, it's going to move slowly or move quickly. And then finally, dawn starts to happen. Those red glows, that's from my own red light, I believe, or somebody else's red light, I'm not sure. On another raft trip, we started off in bright moon. And then the moon would set, and the moonlight, that's not sunlight, that's moonlight, because it's a long exposure. You're going to see when I start it, the stars will be spinning and looking somewhat northward. And the moonlight will creep up, and then after the moonlight creeps all the way up, a moment or two later, the whole sky will get darker, and then dawn will happen. So this is in a waxing phase of the moon. It's going to set fairly early. There it comes, the moonlight creeping up. I love this transition. And then the sky gets dark. And then the sky begins to brighten from a rising sun. End of a night. This is the second half of the night we're looking at here. Well, you know, I'm just sharing you a little bit of the wonder and beauty of the heavenly skies with you in this presentation. And again, my life work has been to share the wonder and beauty of God's creation, and also the fact that we can believe in creation as well. But you know, if you just saw some pretty pictures, that's not good enough, because you see, you're missing the point at this point. The important thing is you have to understand there's a creator, and that creator has expectations and demands upon our life, and his standard is one of perfection. And sin has entered into the world, and it's changed that relationship forever. But God in his mercy and in his love for us provided a way of salvation. And he sent his own son, Jesus Christ, into the world to take that penalty of sin for us, and we can believe and have faith in his redemptive work. We can have restoration with the Lord, and we can spend eternity with him. So I encourage you, if you're watching this today, please take it the next step. Don't stop with just these pretty pictures. Thank you for watching.